Welcome back to this amazing platform of Infinity Learn by Sri Chaitanya. And guys, as you all know that I'm your host and host AV. And yes guys, today I'm going to discuss the entire chapter of alcohol, phenols and ether. Okay, so we'll try to cover as much as things possible for us, okay, in today's session. Okay, so let's get started guys. Now, before I move ahead guys, on infinitylearn.com there are several products that we offer to all of you, be it mock test, be it live classroom, be it doubt solving out, and there are n number of things. Okay. And if you really feel to register with us and try some of the products, then I'll rather suggest you to use this code, that is AMAN40, to avail instantly 40% off. Okay, so just a small information to all of you. Now let's get started guys. Okay, so alcohol, phenols and ether. Before I get started, if you are new to the channel, please make sure that you are going to subscribe our channel. Okay, do not forget to subscribe, and yes, please hit the bell icon so that you can get all the recent updates, okay, of whatever session that we are going to take in this platform. Okay, and yes, do not forget to like, comment, share the channel with all your friends, those who are going to give NEET 2022. Okay, so we'll divide this chapter in three different segments. Okay, we'll divide this chapter in three different segments, and that all three different segments will be, the first one will be alcohol. Okay, the first I'll be discussing is the alcohol. The second that I'm going to discuss is phenol. Okay, and the last one will be ether. Okay, talking about the importance of all this chapter. Okay, so alcohol, apart from this thing, there are two things that we are going to discuss, as I've already mentioned, that is phenol and ether. Out of all these things, I want to give the priority order of the NEET, okay, in which the question can come with the most prior is alcohol. But yes, you can expect at least one question from this segment of phenol, and ether may or may not come. Okay, ether may or may not come. So my main focus will be on phenol as well as alcohol, and I'll try to cover most of the segment of this alcohol and phenol topic. Clear guys? Sure. Perfect. Great. Now, proceeding further, alcohol. First of all, you should know something about alcohol, and that is, let me just erase whatever the things are there on the slides. Yep. Now, talking about alcohol, the first thing that you should know, its functional group. Okay, alcohol has a functional group, that is OH. Okay, it is represented by a functional group OH. It's in IUPAC, its name is all, and common name, okay, it is hydroxy. If it acts as a substituent, it is hydroxy. If it does not act as a substituent, it is an alcohol. Clear? Sure. Perfect. Let's proceed further. So that is all about the representation of alcohol. Okay, that is in terms of functional group, and their IUPAC and common name. Now, exactly what is an alcohol? Alcohol, okay, may be defined as a particular hydroxy derivative of an alkane. Okay, so what exactly that means is, suppose if I take, okay, suppose if I take an alkane, okay, suppose if I take an alkane, alkane can be represented by RH, whereas the general molecular formula of alkane is CnH2n plus 2. Okay, the general molecular formula of alkane is what? CnH2n plus 2. Now, what basic thing that we need to do is we have to remove hydrogen from here, and we have to add OH. Okay, what I'm going to do is, by any process, right now process is not that important. What we are doing is we are removing hydrogen from here, and we are adding hydroxy group into it. Okay, clear? So the same group or the same alkane will get converted to ROH. Now, since OH has been introduced in alcohol, its name becomes alkanol. The IUPAC name of alcohol is what? Alkanol. And its molecular formula will become CnH2n plus 1 OH. This is one way to say, or you can also write it as CnH2n plus 2 O. Okay, clear? And that's how the definition of alcohol goes, my dear. Alcohols are the hydroxy derivative of aliphatic hydrocarbon, in which one or more hydrogen are replaced by the corresponding number of hydroxyl groups, and depending upon the number of hydrogen that is getting replaced by OH group, they are further classified, that we are going to see in a short period of time. Okay, clear? So that is the basic introduction or the definition of an alcohol. Talking about the examples, guys. Okay, talking about the examples. Wait a sec. Yeah, talking about an example over here. If I take methane, okay, if I take methane, what happens is, okay, if I take methane, what happens is, if I remove one hydrogen from methane and add OH group, it will get converted to what? CH3OH. That means CH4 gets converted to CH3OH and methane gets converted to methyl alcohol. Some of the things that you should remember about this, some of the things, it is also known as methyl alcohol. Okay, it is also known as what? Methyl alcohol, or it is also known as wood spirit. These are some different names of methanol that I am sharing with all of you. These are some different names of methanol that I am sharing with all of you. Okay, then it is also known as let me just remember it. Okay, it's methyl alcohol, wood spirit, and yes, carbinol. This is also one of the name given to what? Alcohol. So it is also known as what? Carbinol. Okay, and guys, it's a request to all of you, if you have any doubts, any difficulties, please make sure that you are going to post it in the chat box. Okay, so yeah, that is a basic introduction, guys. Okay, that's a basic introduction about what? Alcohols. Okay, now talking about its classification. Okay, classification of alcohol will take place depending upon the number of OH group present in a molecule. Okay, so on the basis of this, okay, it gets classified into monohydric alcohol, dihydric alcohol, trihedric alcohol, and polyhydric alcohol. Talking about the monohydric alcohol, okay, if I talk about monohydric alcohol are the alcohol which contains, okay, it contains only one OH group. It contains only one OH group. Talking about dihydric alcohol, it contains two OH group. Okay, it contains two OH group, whereas it will contain how many? 3 OH group. Talking about the last one, polyhydric alcohol, it will be at basically the basic classification should be monohydric and polyhydric. Polyhydric consists of di, tri, tetra, and so on. So for polyhydric, since I have already covered trihydric, I am going to say more than 3 OH group. More than 3 OH group. So this is how the alcohols are classified. Monohydric alcohol are the alcohol which consists of only one OH group. Dihydric alcohols are the one which consists of 2 OH group. Tri is 3, poly is many. Okay, talking about their examples, one we have already seen methanol. The another that I am going to explain over here is ethanol. The another example that we are going to take is what? Is an ethanol. Okay, talking about dihydric alcohol, here I am going to take ethylene glycol. Please remember this name. This is the particular compound that you are going to listen so frequently. Ethylene glycol, and ethylene glycol can be represented as CH2, OH, and OH. Okay. Hello Subiksha. Welcome to the session. Talking about trihydric alcohol, I am going to take example as glycerol. Okay, I am going to take example of what? Glycerol. Please remember this thing. This glycerol is nothing but equal to glycerin. I hope you must have seen so many serials and movies in that they use particular liquid to shoot a crying scene where the tears are not original. That tears are basically nothing but glycerin. तो yes, ये रोने के लिए काम आता है, ठीक है. So please ध्यान रखना glycerol किस लिए काम आता है, रोने के लिए. That is nothing but a part of glycerin and it can be represented as CH2, CH, CH2, okay, OH, 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 okay. And talking about the last one, more than 3 OH group, one specific alcohol which I'll like you all to remember is this, that is sorbitol. Okay, sorbitol is hexahydroxy alcohol. Sorbitol is what? Hexahydroxy alcohol. Its name is what? Sorbitol. Also known as glucitol because it is been obtained from glucose. Also known as what? Glucitol. And second, the glucose is from the aldehyde family. That's why it is also known as what? Alditol. Okay, so sorbitol, glucitol, alditol. Now please do not ask me whether Dettol is from the same family. It is absolutely not. Okay, so Dettol is not from the same family. Jokes apart, guys. Yes, but yes, this is a particular thing that I'll tell you to remember this thing. Okay, clear. Perfect. Now, one important thing which again I like to highlight over here, that is again an important stuff. Ethylene glycol is basically an vicinal diol. It is basically an what? Vicinal diol. And you have to remember that most of the geminal diol are unstable, and does not exist. Are unstable and does not exist. They are unstable and they do not exist in nature. Okay, please remember that thing. One more shortcut that I can give it to you over here is, if a carbon atom consists of 2 OH group like geminal diol, okay, you should remember that it will get converted to either aldehyde or a ketone group. Okay, this is one thing that you should remember. Okay, and the next thing that you should remember is, if a carbon atom consists of 3 OH group, then it will give you a carboxylic, that will give you what? A carboxylic acid. So that's why geminal diol are highly unstable and they do not exist. What exists, the moment it is formed, it undergoes dehydration to give you corresponding aldehyde, ketone or carboxylic acid depending upon the OH group attached. Okay, is that thing clear? But yes, I should not deny the fact that ki sare hi nahi hote. Yes, there are some geminal dialcohol that exist, but they exist in water. Okay, they exist in water. You cannot isolate a geminal dialcohol completely, because the moment you try to isolate, their stability factor which has been offered in the solution will be gone, and again it will become unstable, and since it is unstable you cannot isolate it. So yes, geminal diol whatever exists, जो भी exist करता है वो कहाँ exist करता है, it basically exists in what? Water. So please इस चीज़ को अपन याद रखेंगे. Okay, clear? So I hope there is no doubts, no difficulties till now. Okay, अगर कोई भी doubt difficulty है तो please make sure that you are posting in the chat box. Okay, perfect, great. Now proceeding further, monohydric alcohol, as I said, it gets classified into 2 types. Okay, that I have already discussed with you. Monohydric alcohol get classified into vicinal diol, which we have already discussed in the form of ethylene glycol, and the second one is geminal diol, which I have already given you an idea. Okay, tri and polyhydric we are not interested. We are more interested in the classification of monohydric alcohol. Okay, monohydric alcohol further get classified into several types. Okay, although the in detail classification is a different case, but since it is a one-shot video, I am not going to discuss the entire detailed classification. But yes, there are some names that you have to remember. That is names like alkyl alcohol, then allyl alcohol, then benzyl alcohol, and then vinyl alcohol. Okay, so yes, this monohydric alcohol further get classified into alkyl alcohol, allyl alcohol, benzyl alcohol, and the last one is vinyl alcohol that you have to remember. One more is there, aryl alcohol, but that aryl alcohol is nothing but a phenol that we are going to discuss in a different chapter. Okay, yeah. Talking about alkyl alcohol are the particular alcohol in which the OH group, okay, let me just clear this thing, let me just give you the idea over here. Yeah, alkyl alcohol are the particular alcohol in which the OH group is directly bonded to sp3 hybridized carbon atom, in which the OH group is directly bonded to what? sp3 hybridized carbon atom. Whereas talking about allyl alcohol is the particular alcohol in which again it is bonded to sp3 carbon atom only, but that sp3 carbon atom is directly bonded to sp2 carbon atom. Okay, so this is sp3, and if you'll see this sp3, it is directly bonded to what? sp2 carbon atom, and such kind of an alcohol is known as what? Allyl alcohol. Okay, talking about benzyl alcohol, again the concept is same, but the only difference is this sp2 carbon atom will be the part of benzene ring. This sp2 carbon atom will be the part of benzene ring, something like this. Okay, so I am creating a benzene. So this is benzene. So this is an sp2 hybridized carbon atom, right? And it is bonded to again an sp3 carbon atom, and OH is bonded there. So again this is sp3. This carbon is sp3. This carbon is sp2. So the same concept, sp2 and sp3, and then comes the OH. But over here that sp2 carbon atom should be the part of benzene ring. Only benzene ring, not cyclohexane ring. It has to be a part of what? Benzene ring. Okay, and the last one, vinyl alcohol. Talking about vinyl alcohol, it is directly bonded to sp2 hybridized carbon atom, and vinyl alcohols are basically unstable and they normally undergo a process known as tautomerization. Okay, you must have studied this thing in your 11th standard when the tautomerism was taught. So basically vinyl alcohols are unstable and they quickly undergo what? Tautomerization to again give you what? Aldehyde or a keto. That is keto in or tautomerism. Okay. Talking about its representation, some of the representation that I can show it over here is, first representation it is R CH2 OH, okay, then R CH R OH, then R C R R OH. Okay. Similarly, allyl alcohol can be represented as CH2 double bond CH CH2 OH, then CH2 double bond CH CH OH, and there is one valency R over here, and then the last one CH2 double bond CH C R R OH. Talking about benzyl, it is phenyl group, then CH2 OH, then again phenyl group CH2 OH with R over here, then again phenyl group C R R OH. Okay, now basically what I've tried to do over here is this alkyl alcohol, allyl alcohol and benzyl alcohol further get classified into again three types of alcohol, that is primary, secondary and tertiary alcohol. Primary, secondary and tertiary alcohol, where primary alcohol can be identified by a functional group CH2OH, so this becomes primary alcohol. See, again CH2OH, again it becomes primary alcohol. Again CH2OH, it becomes what? Primary alcohol. Okay, 1 degree alcohol. Talking about CHOH, it forms the secondary alcohol. Okay, CHOH, it forms the secondary alcohol. Okay, CHOH, it forms the secondary alcohol. Third one, COH, COH and COH, it forms 3 degree alcohol. It forms what? 3 degree alcohol. A detailed class of degrees of alcohol, halides, amines I have taken on this platform itself. You can just go and visit the playlist. You will see that I have taken one of the class where I have discussed in details how to identify the degrees of alcohol. And this is really important, guys, because this degree of alcohol will play a very important role in determining the reactivities of alcohol. Okay, So that was all about the classification of alcohols. Okay, from the classification, now let us proceed with the methods of preparations of alcohol. Okay, now we'll be proceeding what the methods of preparations of alcohol. Okay, so the first method that comes is from alkene. Okay, the first method that comes is from what? Alkene. Okay, so let us take an alkene over here. This is an alkene that we have taken. Okay, and there are three methods. Okay, first of all, let me write their names properly. Okay, ACH. Okay, ACH is nothing but acid catalyzed hydration. I'll write the name over here. It is what? Acid catalyzed hydration. This stands for what? ACH. Okay, so I hope guys this has been visible to every one of you out there. I hope it has been visible to you all. Okay, talking about acid catalyzed hydration, this can be represented, or the condition can be represented as dilute H2SO4. Okay, or they can simply give you H3O plus, or they can give you H plus aqueous. Okay, they all are one and the same conditions. They all are what? One and the same conditions. So that is all about what? ACH. Not the reaction, just the discussion point of view. Talking about OMDM. Talking about what? OMDM. Okay, OMDM is nothing but oxymercuration. Okay, it is what? Oxymercuration and demercuration. Okay, oxymercuration and demercuration. Okay guys, so this is the concept of what? This is the concept of what? OMDM. Now talking about its reaction guys. Okay, talking about its not reaction, talking about its condition. First of all, what we add is mercury acetate. In the first step, what we add is Hg. Okay, the first step is what? Addition of what? Mercury acetate. That goes for oxymercuration and demercuration. It forms a non-classical carbocation. And since there is a formation of non-classical carbocation, it will not undergo rearrangement. Second step is the reduction step. That is by adding NaPH4. Okay, the second step is what? The reduction step. Okay, talking about the last one, HBO. It's not a channel. Okay, HBO is not a channel. It's a shortcut for Hydroboration Oxidation. Okay, it is what? Hydroboration Oxidation. Okay, in this, the condition or the reagent that has been used, the first reagent is what? Either you can use B2H6, that is diboron, or what you can use is BH3 in THF. Okay, clear? Sure. It's a concerted mechanism. That means each and everything will take place in a single step, and then there is no chance of formation of carbocation. Okay, second step is oxidation step. The first one is hydroboration, and the second one is the oxidation step. It takes place in the presence of peroxide and a base. Okay, clear? Now you have to carefully see the product that I am going to mark. First of all, I am going to write the substrate as it is in spite of double bond. Okay, so this is the substrate, and in all the cases, okay, and in all the cases, the only thing that is going to happen is the addition. What is going to happen is the addition of HOH. I hope you must have understood, guys. The only thing that is going to happen is the addition of HOH, right? So in the first case, OH, H. Second case, OH, H. Third case, H, OH. Okay, so there are some pointers that you have to remember when it comes to acid catalyzed hydration, okay, or OMDM. You can see the product is same, but when it comes to hydroboration oxidation, you can see the product is different. Okay, and whenever an unsymmetrical alkene is added to an unsymmetrical reagent, you know that either the Marconi rule is followed or the anti-Marconi rule is followed. So in the first case, I'll say that Marconi rule is followed, and I'm going to abbreviate it as MR. Okay, the first rule is Marconi rule. But yes, you do not have to apply this rule blindly, because in this particular reaction mechanism, carbocation has been formed. What has been formed is what? Carbocation. Okay, and since carbocation is formed, this carbocation will rearrange. Okay, this carbocation will rearrange, and since carbocation rearranges, that means if there is a possibility of a 2-degree alcohol to get converted into a 3-degree alcohol, that rearrangement will take place. And you don't have to worry, guys, we will definitely discuss one of the question on the rearrangement as well. Rather, I'll take a single substrate in which I'll show you the rearrangement, no rearrangement, and the other aspect of the reaction as well. Okay, so rearrangement will take place, and the major product over here is either 2-degree or 3-degree alcohol. Either 2-degree or 3-degree alcohol. Talking about this case, again, Marconi rule is followed. Okay, Marconi rule is followed. Carbocation is formed. As I said, a non-classical carbocation is formed. Okay, but no rearrangement. So no carbocation rearrangement. Means a 2-degree alcohol cannot get converted into a 3-degree alcohol. Okay, last one is, if you can see, the negative part has gone to the carbon containing more number of hydrogen, so it is known as AMR, that is anti-Marconi rule. Okay, no carbocation formation. Okay, so no carbocation formation, and the major product over here is 1-degree alcohol or max to max 2-degree alcohol, and from HBO you cannot prepare 3-degree alcohol. Clear? Any doubts, any difficulties over here? So I hope, guys, I have given you a brisk idea about what the acid catalyzed hydration, oxymercuration and demercuration, and hydroboro oxidation or hydroboration oxidation. Okay, any doubts, any difficulties, guys? Any doubts, any difficulties? No one? Sure? Perfect. Let us discuss this thing with the help of an what? Example. Okay, so this is the example, right? No, sorry. Okay, so basically it is an example, right? Now all we have to do is what? To add water. In the first case, there will be a formation of carbocation. Okay, so let us form that carbocation. So CH3, C, CH3, CH, CH, CH3, there is a formation of what? Carbocation. And since this carbocation is what? A 2-degree carbocation, it will rearrange. Okay, it will rearrange and it will undergo 1, 2 hydride shift. It will go what? 1, 2 hydride shift. And the moment it undergoes 1, 2 hydride shift, the product that is going to form is CH3, C, CH3, CH2, CH3, and there will be a carbocation over here. And now this time the carbocation which has been formed is 3-degree. Okay, over here the number of alpha hydrogens. Okay, over here the number of alpha hydrogen was 4 alpha hydrogen. Okay, it was how much? 4 alpha hydrogen. Over here the number of alpha hydrogen is 8 alpha hydrogen. So that's why it is more stable. That's why it is what? More stable. And hence finally the product that will be formed is CH3, C, CH2, CH3, and over here again CH3. Okay, and this is a 3-degree alcohol. Okay, alcohol I have not placed, OH. Right. Talking about OMDM, directly we have to add water, and apply Marconi rule. Directly apply what Marconi rule. So what will be the product? CH3, CH, CH, CH3, OH, CH3. Okay, and over here if you can see, it is an 2-degree alcohol. Okay, talking about the last one, that is HBO. Okay, HBO follows what? Anti-Markovnikov rule, and according to anti-Markovnikov rule, it says that negative part of the reagent to carbon containing more number of hydrogen. So the product that will be formed is CH3, C, CH3, CH, CH2, CH2, OH. That is what? Primary alcohol, secondary alcohol, and tertiary alcohol. Okay guys, sure. Any doubts, any difficulties? Any doubts, any difficulties to anyone guys till now? No one? No one? Perfect, great. So yeah, there is no doubt, no difficulties. So I am ready to move ahead. So that was what? Formation of alcohol, that is monohydric alcohol. Now I will be discussing the formation of diols. Okay, now we'll be discussing what? The formation of diols, and this is the example that I am going to take. Okay, first of all, cold dilute alkaline KMnO4. You have to remember this reagent. It is known as Bayer's reagent. Okay, this reagent is known as what? Bayer's reagent, and the reaction is known as Bayer's reaction. Okay, in the last one you can say it is in peroxy acids. This is what? Peroxy acid. Peroxy acid, or you can take peroxy carboxylic acid. It can be represented as R, C, double bond O, 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 H. And since it is in peroxy acid, the first process is known as epoxidation. That means formation of epoxides. Epoxides are nothing but a 3-membered ring in which one member is one member is oxygen. Okay, it's a cyclic ring, 3-membered cyclic ring in which one member is what? Oxygen. Okay, clear. And since there is a formation of diol, what is getting added is OH and OH. And since the symmetrical thing is getting added, no Markovnikov's or anti-Markovnikov's will be applicable. But over here, the addition type is definitely applicable. Okay, clear. When you apply Bayer's reagent, it will undergo syn addition. For osmium tetraoxide also it shows syn addition. Okay, but for epoxidation it shows anti-addition. What does exactly that means? It means, okay, it simply means if I mark the product of first two, okay, if I mark the product of what? First two, it can be represented as R, CH, single bond, CH, R, and both the OH group will get added from the same side. Okay, both the OH group will get added from the same side. That means from this side and from this side. The addition is exactly from the same side. Clear? But if I talk about this anti-addition, if I talk about this what? Anti-addition. So its addition and the product will be R, CH, CH, R. Okay, in this thing what happens is, if one OH is getting added from this side, the another OH will get added from the opposite side, and hence the product, you can see, it will be something like this. Okay, the product that you can see is something like this. Okay, the base are what? Basically they both are what? Diols, but their orientations are different. And depending upon the orientation, they can be a meso compound, they can be a diastereomers, or they can be an enantiomers of each other. Okay, again I'll say they can be a meso compound, they can be a diastereomer, or they can be an enantiomer of each other. Okay, just to give you a hint, I'll give you an example of car and TAM. Okay, car, you remember this thing? Car stands for cis. If the alkene is cis, Okay, if this given alkene, given alkene can be cis or trans as well. If it is not cis or trans, this what we say, if it is not a cis and trans alkene, or basically if alkene do not show geometrical isomerism, the diastereomers or enantiomers and meso compound does not exist. So if the alkene shows geometrical isomerism, then and only then you can see an optical isomerism. Okay, so it has to be a cis or trans. So if the alkene is cis and the addition is anti-addition, then it forms a racemic mixture. Racemic mixture means what? Enantiomers. That is car. Talking about TAM, it is again, if the alkene is trans alkene, addition is again anti, okay, hence it becomes meso compound. So yes, these are the shortcuts that you can use for, see, this is for anti-addition. For syn addition, it will be opposite of it. Okay, clear? So just to give you a hint, they are again what? Diols, but yet depending upon the addition, their optical isomerism or stereo isomerism may change. Okay, clear? Any doubts, any difficulties, guys? Any doubts, any difficulties to anyone? No one? Sure. Perfect. So let's proceed further, and in that now we'll be discussing about the reaction of Grignard's reagent. This RMGX that you can see over here is what? Grignard's reagent. It is what? Grignard's reagent. Okay. So what happens when Grignard's reagent is treated with formaldehyde? Okay. Formaldehyde. Here all the aldehyde, but except formaldehyde. All the aldehyde except formaldehyde. Except formaldehyde. Okay, and the last one is keto. And the last one is what? Keto. Okay, so I'll give you a basis of all the reactions. Okay, I'll give you a basis of all the reaction, but you should know the product name as well. When Grignard's reagent, let me mark it as GR. Okay, when Grignard's reagent is treated with formaldehyde, okay, when Grignard's reagent is treated with formaldehyde, all you are going to get is 1 degree alcohol. Please remember this thing. All you are going to get is what? 1 degree alcohol. Okay, when Grignard's reagent is treated with aldehyde except formaldehyde, that aldehyde should not be formaldehyde, right? Any aldehyde will do. You will get 2 degree alcohol. You will get what? 2 degree alcohol. And finally, when it's treated with a ketone, okay, you will get 3 degree alcohol. Okay, so Grignard's reagent plus formaldehyde is 1 degree alcohol. Grignard's reagent plus acid aldehyde or any aldehyde apart from formaldehyde is 2 degree alcohol, and the last one, Grignard's reagent plus ketone, is what? 3 degree alcohol. Now let us see the basis of reaction. Okay, let us see the basis of reaction. See, double bond O plus RMGX. Okay, and this reaction takes place always in the presence of dry ether. We know that magnesium is partial positive because it's in metal, so R becomes partial negative. In this carbonyl group, oxygen is partial negative and carbon is partial positive. So this negative part, that is R group, attacks on partial positive carbon. Carbon forms a pentavalent, that is not possible, and hence it breaks the pi bond towards oxygen. Oxygen becomes negative, and this negative oxygen takes away the magnesium part, and it forms a complex that is known as magnesium complex. O, MgX and R. Okay, so this is the complex that has been formed. Okay, where again oxygen gets a negative charge and magnesium gets this time a pure positive charge, and there is sort of ionic bonding. Last step is the hydrolysis step. Last step is what? The hydrolysis step. And in hydrolysis, what happens is, again, H gets attached over here and OH gets attached over here. Okay, and finally the product that has been formed, okay, and finally the product that has been formed is OH and R. Okay, clear? Now let us assume that this 2 valency that has been free, both are hydrogen. This 2 valency that has been free, they both are what? Hydrogen. And since they both are hydrogen means what? They both are formaldehyde. So the remaining, can I write it over here as this is what? Hydrogen. And the place where OH is bonded, that carbon is only bonded to one other carbon atom, and hence can I say it is an 1 degree alcohol, which can be represented as R CH2OH if both are hydrogen. So hence proved for Grignard's reagent plus formaldehyde is what? Primary alcohol. Now what I'll do is I'll remove one hydrogen from here. Okay, what I'll do is I have removed one hydrogen and I'll add an aldehyde, one R group. So now it becomes aldehyde. It can be any aldehyde, but it cannot be formaldehyde, because for formaldehyde both hydrogens are required. Okay, so let me mark over here R, right? What will be the new product form? R CH R OH, which is nothing but this time it is what? A 2 degree alcohol. First it was a primary alcohol, now it is what? A 2 degree alcohol. Hence proved if I'll take RCHO. Okay, that means any aldehyde. Last one, I'll remove the remaining hydrogen as well. Okay, and now what I'm going to place it over here is to make R. Okay, I'll place R to make it what? A ketone, right? So now a ketone reacts with Grignard's reagent to give you what? A 3 degree alcohol. A 3 degree alcohol. Got it, guys? This is how, okay, this is how the reaction takes place. This is how a reaction with Grignard's reagent and aldehyde and ketones takes place. Any doubts, any difficulties to anyone? Any doubts, any difficulties to anyone, guys? Anyone out there? No one? Chalo, perfect. Let's proceed further. Okay, now we'll be talking about catalytic hydrogenation of aldehyde and ketone. This catalytic hydrogenation of aldehyde and ketone can also be termed as reduction of aldehyde and ketone. Okay, let me mark that thing over here. It is also a part of what? Reduction. Obviously, I'm going to discuss reduction in the next slide. But yes, this also you can consider as what? Catalytic hydrogenation means what? The reduction of aldehyde and ketone. Clear, guys? Sure. Now, talking about the general reaction of it, it is C double bond O single bond. Okay, this can be an aldehyde. Okay, it can be a ketone. It can be an aldehyde or it can be a ketone. What we are doing is we are hydrogenating it. That means in the presence of hydrogen. And since it is a catalytic hydrogenation, there has to be a presence of catalyst, and the catalyst can be nitrogen, not nitrogen, sorry, nickel. Oh, sorry. No, the catalyst can be nickel, platinum, palladium, or a special catalyst known as Rane nickel, or a special catalyst known as what? Rane nickel. Either one of the metal can be taken, and yes, heating is must. And then you have to what? Heat it. Especially when it is nickel and Rane nickel, heating is required. Okay. So what happens is this hydrogen are both attacks on what? C double bond O, and converts this C double bond O, or basically since hydrogen is getting added, and C double bond O will get converted to what? COH. Okay, so the product that will be formed over here will be OH, and one hydrogen is added over here. Okay, clear? Remember, if these two valencies are different, okay, I must write this thing. If both valencies are different, if both the valencies are different, then the alcohol is chiral alcohol. Then the alcohol is what? Chiral alcohol. If both the valencies are different, please make a note of it. If both the valencies are different, we'll be discussing that examples as well. But yes, let us first understand which formaldehyde. Okay, so there is H, C, double bond O, H. I am adding hydrogen in the presence of nickel and heat. I am not writing entire stuff now. Okay, just either one metal and then heat. So can I say that it will get converted to H, C, OH, H, H, or I can also write it as CH3OH. This is methanol. Okay, the product that has been formed is what? A methanol. And methanol is what? A 1 degree alcohol. Okay, second. Let us take other aldehyde except formaldehyde. Okay, the aldehyde that we have taken over here is formaldehyde. Okay, clear? Now let us take other aldehyde, that is CH3, C, double bond O, H plus hydrogen is added. This time let us take platinum and heat. Okay, so what will be the product? CH3, C, OH, H, H, or CH3, CH2, OH. So the product that is formed is what? Ethanol. Okay, which is again a 1 degree alcohol. Okay, so in presence of aldehyde, okay, in presence of what? Aldehyde and formaldehyde. Okay, you take any aldehyde. Okay, what you are getting is what? Primary alcohol. Let us take the third reaction, and this time I am going to take a ketone, that is CH3, C, double bond O, CH3 plus hydrogen in the presence of Rani nickel. The product will be what? CH3, C, OH, H, CH. This is isopropyl alcohol. This is what? Isopropyl alcohol or propane to all. And isopropyl alcohol or propane to all is what? A 2 degree alcohol. That means if you take aldehyde, you will get 1 degree alcohol. And if you take ketone, you will get 2 degree alcohol. By reduction of aldehyde and ketone, you cannot prepare 3 degree alcohol. Please make a note of it, guys. By reduction of aldehyde and ketone, you cannot prepare 3 degree alcohol. That's a very important concept. Please make sure you make a note of it. Okay. Now, if you'll see, both the valencies are still the same. Let us take a particular compound in which both valencies are different, and for that thing I'll bring butanone. Fourth one, I'll bring what? Butanone, that is CH3, C, double bond O, C2H5 plus hydrogen in the presence of nickel and heat. The product that you will be getting is CH3, C, OH, H and C2H5. Clear? Sure. And since all the group on this carbon atom is different, this becomes what? Chiral. This becomes what? Chiral. And that's why you can form dextro or levo, both the compounds, or basically the mixture will be what? The mixture will be what? A racemic mixture, or enantiomers can be formed. Okay, so that was all the details that was required for you all to know about catalytic hydrogenation of aldehyde and ketone, also termed as reduction of aldehyde or ketone. Let me know in the chat box, guys, if you have any doubts, any difficulties. Please let me know in the chat box if you have any doubts, any difficulties over here. Anyone? Any doubts, any difficulties till now? No one? Sure. Guys, any doubts, any difficulties? Any doubts, any difficulties, guys? No one? Sure. Perfect. Great. Let's proceed further. Okay, let's proceed further and discuss the next aspect of the reaction, that is reduction of aldehyde and ketone by using some reducing agents. Okay, by using some reducing agents. Okay, and the reducing agents that we are going to use. Okay, the reducing agent that we are going to use is first one, lithium aluminium hydride. Okay, lithium aluminium hydride, and always remember lithium aluminium hydride is always kept in the presence of dry ether. Okay, this is the first reducing agent that we are going to use. Okay, second second you can use sodium borohydride. Talking about the intensity, lithium aluminium hydride is more stronger than the sodium borohydride because over here all the hydrogen atoms are bonded to a metallic aluminium. Okay, whereas over here hydrogens are bonded to metalloid boron. Okay, that's why the reactivity of lithium aluminium hydride is more. Its reducing property is also more. But one thing you have to remember that they do not reduce carbon to carbon bond, and hence unsaturated alcohol can be prepared. So first thing, we know that lithium aluminium hydride, they both are the source of what? They both are source of H minus ion, that is a nucleophile. C double bond C is also a nucleophilic center, and that's why they do not interact. And since they do not interact, this cannot reduce carbon to carbon double bond. Okay, clear? Now, no doubts to anyone? Perfect. Proceeding further over here, guys. C double bond O C, and what we are using is lithium aluminium hydride. What we are using is what? Lithium aluminium hydride in the presence of dry ether, followed by, the moment you use dry lithium aluminium hydride, it has to be always followed by H3O plus. It has to be always followed by what? H3O plus, and the product that will be formed, okay, and the product that will be formed is C double bond OH, sorry, C single bond OH and H. Okay, now I am writing this OH in this format because I need to share something important with you. Okay, I need to share something important with you, and that is, see guys, I am highlighting this H over here. I am highlighting this H over here, and then again I am highlighting this H over here. Okay, the reason I am doing it is you have to remember one important thing over here. This H, it comes from solvent. It comes from solvent. Okay, whereas this H, it comes from this, you have to remember. One H comes from solvent and one H comes from what? Reducing agent. How? See, right. In this carbonyl group, oxygen is partial negative, whereas carbon is partial positive. Right? Second important thing, this lithium aluminium hydride is going to produce H minus ion. Right? So this H minus ion, it can come and attack to this carbon for sure. But this H minus ion cannot come and attack to this oxygen. This is not possible. Why? Because this is also negatively charged species and this is also negatively charged species. So they both will what do? What both will do? They will repel each other. And that is the reason this hydrogen is definitely not coming from the reducing agent. And the another source of hydrogen is what? This solvent. And that's why this H plus oxygen minus extract this H plus from you. Okay, from the acidic medium. Is that thing clear? So please remember, while doing the reduction of aldehyde in ketone in the presence of lithium aluminium hydride or sodium borohydride, okay, the hydrogen which is bonded to oxygen, okay, or the hydrogen which attacks to carbonyl oxygen comes from the solvent, and the hydrogen which attacks to carbonyl carbon comes from the reducing agent. Okay, second thing, aldehyde plus reducing agent will only give you primary alcohol, that is 1 degree alcohol. Okay, then ketone plus reducing agent gives you 2 degree alcohol. 3 degree alcohol cannot be cannot be prepared by 3 degree alcohol cannot be prepared by reduction of aldehyde or keto. Okay, 3 degree alcohol cannot be prepared by reduction of aldehyde or a keto. Is that thing clear? Is that thing clear to everyone? Sure. Any doubts, any difficulties to anyone? Any doubts, any difficulties to anyone? No one? Chal. Great. Perfect. Perfect. So, proceeding further from here, chemical properties. So, before we start our chemical properties, let's have a break of 2 minutes and then we'll get started with what? Chemical properties. Okay. So guys, let's get started once again. Okay, so we have already covered with methods of preparations. Now we'll be talking about the chemical properties of what? Alcohol. Okay, now we'll starting with what? The chemical properties of alcohol. So talking about how exactly alcohol reacts, there are two ways. Okay, there are basically two ways in which the alcohol shows reaction. So alcohol are OH. This is the general representation of what? An alcohol. And as I said, it shows the reaction in two different ways. First and the second way. In the first way, the alcohol, it acts as an acid. Okay. In the first way, alcohol acts as an acid, and since it acts as an acid, it undergoes an heterolytic cleavage of oxygen and hydrogen bond. And since it undergoes heterolytic cleavage of oxygen and hydrogen bond, it forms RO minus ion, which is also known as alkoxide ion. Which is known as what? Alkoxide ion, and this H plus ion is liberated. Okay, either the H plus ion is liberated or the hydrogen gas is been liberated. Okay, and in the second case, it acts as a base. And in the second case, it acts as a what? Base. Okay, and base means, okay, base means in spite of this oxygen and hydrogen cleavage, it undergoes ROH cleavage by donating its lone pair of electron to a proton donor. Okay, so it forms something like this. Suppose H plus is a acceptor, lone pair acceptor, so it forms something like this. And now, depending upon the stability, this cleavage will take place. Okay, cleavage will take place as in it might undergo an SN2 reaction mechanism, or it might undergo SN1 reaction mechanism, depending upon what the R group is all about. Okay, if carbocation formed is a stable carbocation, okay, so then it forms R plus NH2O directly. Carbocation will be formed, and the mechanism that will be followed is SN1 mechanism that you know about. Okay, if carbocation is not stable, okay, then it undergoes what? SN2 reaction mechanism. Okay, so first we'll be discussing about the reactions of alcohol in form of acid, and then we'll be discussing the reaction of alcohol in terms of base as well. Okay, so let's start. Okay, the first one, reaction of alcohol as an acid. Okay, the first reaction is, it's a justification that alcohol shows acidic behavior. Okay, one important thing that I might want to write over here. Okay, Okay, let me just change the color. Okay, I'll take a different color so that you should remember this pointer. Okay, and I hope this color will be visible. Okay, and it says that alcohol are not acidic in nature. Alcohol are not acidic in nature, but it shows acidic property. Please remember this thing, my dear student. They are not acidic in nature, but they shows what? Acidic property. So please remember this thing without fail. Now, what exactly is an acidic property? In your lower standard, that is in 10th standard or 9th standard, you might have done this experiment where you add zinc granules in acids like HCl or H2SO4, and what you observe is there is a bubbling of what? Hydrogen gas, and this gas burns with a popping sound. So basically, when a metal is added to an acid, it liberates what? Hydrogen gas. This is what we have proved in lower standard. The same thing happens. Okay, the same thing has been experienced when, okay, the same thing is experienced when sodium is added to alcohol. The moment sodium is added to alcohol, it forms a compound known as RONA. That means this sodium will displace this hydrogen from here, okay, and there will be a bubbling of what? Hydrogen gas. And what is formed is RONA. Okay, I remember this thing for one of the special reaction. If you remember, RONA is used for Williamson synthesis. Okay, please remember this thing. It has been used for what? Williamson's synthesis, and Williamson synthesis is used to prepare ethers, be it a symmetrical ether or be it an unsymmetrical ether. So please remember this thing. We have studied this thing in your 12th standard chapter known as alkyl halides or haloalkanes and haloarenes. Okay, so again what has been formed is sodium alkoxide. What is formed is what? Sodium alkoxide. So that is again a reaction of what? That is again a reaction of what? A reaction that shows alcohol shows acidic behavior. Similarly, when alcohol is added with NaOH, so it gives you RONA plus H2O. Okay, again alkoxide. Similarly, when a stronger base than NaOH is added, again it will give you what? RONA plus NH3. Right. Similarly, when sodium hydride is added, again RONA plus NH3. Right. Similarly, when sodium bicarbonate is added, it will give you RONA plus H2CO3. Right. Right. But this is the biggest mistake that you all do. This is the biggest mistake that you all do. Alcohols do not show sodium bicarbonate test. Let me write it over here. Okay, let me write it over here for you all. Alcohol do not show sodium bicarbonate test. Please remember this thing. Okay, so please remember this thing. It do not show sodium bicarbonate test. Reason: alcohols in acidic order comes after bicarbonate, and the acids which comes above the bicarbonate or bicarbonic acid has tendency to show sodium bicarbonate test. So please make a note of it, guys. Please ये चीज याद रखना. Alcohol do not show any carbonate test. That is sodium bicarbonate test has been not shown by alcohol because it is showing acidic behavior. It is not actually acidic in nature. Even phenols does not show sodium bicarbonate test except picric acid, which is one of the strongest acid. Okay, and it has a pH value of almost equivalent to what? The formic acid. Okay, clear? Sure. Perfect. So that is all about what reactions of alcohol. Proceeding further is we will be talking about what? Esterification reaction. Okay, wait a sec. Proceeding further, we'll be talking about what? Esterification reaction. And in esterification reaction, you can also say it as an acylation reaction. Esterification reaction, you can also term it as what? Acylation reaction. Okay, because in this thing, what basically we do is introduce acyl group. So the reagents that over here we are going to take is a carboxylic acid first of all, and its derivative. And its derivative, like the first that I have taken is what? Carboxylic acid. Okay, we have taken what? A carboxylic acid. Second, what you can use is anhydrides, or wait a sec, yeah, the second that you can use is acyl chlorides. This is what? Acyl chloride. And the last one is anhydride. Anhydride, you can write it as CH3, or in spite of writing CH3 or taking a specific anhydride, let us take that is R dash C double bond O, O, C double bond O, R dash. And whatever you are taking, okay, esterification, whatever you are taking, okay, let me just tell you one important thing over here is this hydrogen is going to get eliminated from alcohol, okay, and from carboxylic acid, this OH will get eliminated. From acyl halide, this Cl will get eliminated, and from this thing, this entire group will get eliminated. Okay, this entire group will get eliminated, and the product for entire ring, you take carboxylic acid, you take acyl chloride, or you take anhydride, the product will be the same, that is R, O, C, double bond O, R dash. That is nothing but an ester. But the byproduct, okay, we'll love to mark the byproducts as well. The byproduct over here, apart from ester, the byproduct over here is water. Over here it will be HCl, and over here it will be carboxylic acid itself. Okay, it will be what? A carboxylic acid itself. Clear? Sure? No. I'll take one specific reaction over here where we'll mark alcohol, okay, alcohol plus carboxylic acid in the presence of concentrated H2SO4, in the presence of what? Concentrated H2SO4, it will give you ester and water. It will give you ester and water, that is RCOOR plus H2O, that is ester. Okay, this ester that has been formed and the water that has been eliminated will dilute this concentrated H2SO4. Okay, it dilutes the concentrated H2SO4 and hence make the reaction reversible. Reversible. So please make a note of it. Makes the reaction reversible, and this esterification reaction is what? A reversible reaction. And this reaction that I have discussed over here is known as Fischer-Spire esterification. Fischer-Spire esterification. Okay, clear? And if you want to produce ester in a more amount, what has been done is water is made azeotrope with benzene and continuously removed. And since it is since the reaction setups an equilibrium and we are continuously removing water from the reaction, can I say that the concentration of product is decreasing? And since the concentration of product is decreasing, the reaction will always move in a forward direction to make up the loss of water, and that is the reason why more and more amount of ester formation takes place. Clear? Sure? Any doubts, any difficulties, guys? Any doubts, any difficulties? No one? Perfect. Great. So that is all about what? Esterification reactions. Okay. Proceeding further, coming upon to the next set of the reaction where the entire OH group will participate in the reaction. The next entire OH group will participate in the reaction, and these are known as what? Dehydration of alcohol. Okay, this is known as what? Dehydration of alcohol. Okay, there is no. Okay, so talking about the dehydration of alcohol, one thing that you should remember over here, whenever an alcohol, okay, whenever an alcohol is been dehydrated, the product that has been formed is an alkene. Whenever an alcohol is been dehydrated, the product that has been formed is what? An alkene. So first thing that you have to remember, dehydration of any alcohol. Okay, dehydration of any alcohol will give you what? An alkene. Yes, there are some alcohols which on dehydration gives ether as well, that we are going to discuss. Okay, basically dehydration we will be discussing in two types: intermolecular and intramolecular dehydration. Okay, so first, an alcohol in the presence of concentrated H2SO4, it gives you alkene, and over here the alkene, we know that there are two types of alkene. One is Sadzef alkene and one is Sadzef alkene and one is known as Hofmann's alkene. So here the alkene that you are going to get is what? Sadzef alkene. Okay, and it's gonna follow even reaction mechanism. And it's gonna follow what? Even reaction mechanism. Okay, clear. Secondly, in presence of dehydrating agent like P2 or P2O5 as well, you will get Sadzef alkene. In presence of alumina also you will get Sadzef alkene. But please remember, in presence of thorium oxide and phosphoryl chloride, you are going to get Hofmann's alkene. You are going to get what? Hofmann alkene. And over here also what you are going to get is what? Hofmann alkene. Please remember it. Okay. And secondly, if you'll see, they all are heated. That means this entire reaction, all this reaction is a gas phase reaction. Okay. Right. This entire reaction is what? A gas phase reaction. Okay. So it's in gaseous. This entire reaction is what? A gaseous reaction. And since the entire reaction is gaseous reaction, they follow E2 reaction mechanism. Okay, they follow what? E2 reaction mechanism. Is that thing clear? So this is the shortcut that you should remember about what? Dehydration of alcohol. You take any alcohol, just remember that Sadzef alkene. What is Sadzef alkene? Which has more number of alpha hydrogen, right? What is Hofmann's alkene? Which has less number of alpha hydrogen. Sadzef alkenes are more stable alkene, whereas Hofmann alkenes are what? And unstable alkene, but not unstable you can say, but yes, it is having less stability as compared to what? Sadzef alkene. The best example I can give you is but1-ene and but2-ene. But1-ene is considered to be an Hofmann alkene and but2-ene is considered to be an what? Sadzef alkene. They both are stable, but but2-ene has more stability than but1-ene. Is that thing clear? Sure. Any doubts, any difficulties, anyone? No one? Perfect. Proceeding forward towards intermolecular dehydration. Okay. The first word itself suggests intermolecular dehydration. Inter means what? When two molecules undergoes dehydration. Okay, when two molecules undergoes what? Dehydration. Okay, clear? Okay, if I have a place over here, yes, I do have a place over here. So I'll just give you a brisk idea about it. So if I take an ethene, that is CH2 double bond CH2. So what I have taken is got an ethene. Okay, so when ethene is treated with concentrated H2SO4, okay, at 443 Kelvin, at 443 Kelvin, sorry, not ethene, it has to be ethanol. So it is CH3 CH2 OH. So it is an ethanol. Okay, so when this ethanol is treated with concentrated H2SO4 at 443 Kelvin, the product that is will be forming will be CH2 double bond CH2, that is ethene. It undergoes dehydration quickly, right? And this reaction, this first reaction is known as intramolecular dehydration. Why it is intramolecular? Because the dehydration is taking place inside ethanol itself. There is no two other ethanol involved. But if the same reaction, if I do the same reaction, that is concentrated H2SO4 again, but I'll decrease the temperature. I'll decrease the temperature to 413 Kelvin, maximum 413 Kelvin. Okay. So the product that will be formed over here is CH3, CH2, O, CH2, CH3. That is nothing but ether. The product that has been formed over here is what? Ether. Clear? And this is known as intermolecular dehydration. So that's why alcohol undergoes two kind of dehydration. First one is intramolecular, and the second one is intermolecular dehydration. Clear? Sure. Any doubts, any difficulties to anyone? Any doubts to any difficulties to anyone? No one? Perfect. So first we are talking about what intermolecular dehydration. The reaction is pretty much simple. You take 2 moles of CH3. You take 2 moles of CH3, CH2, OH, and you have to heat this thing in the presence of concentrated H2SO4 or concentrated H3PO4 at 413 Kelvin, not more than that. At what? 413 Kelvin. The product that will be formed over here is CH3, CH2, O, CH2, CH3 plus H2O, and this is what? Diethyl ether. This is what? Diethyl ether from ethanol. I'll just show you all the steps quickly over here. We are not going to invest more time. First step is the nucleophilic attack. Okay, the lone pair of alcohol attacks on the electrophile that has been provided by acid. I know it is H3O plus, but yes, just to show you quickly, I am just using H plus. What happens is this lone pair attacks. Okay, and the product that has been formed, is CH3, CH2, OH2 plus. Okay, this is the first step. In the second step, the another molecule of alcohol, that is, wait a sec. In the second step, what happens? The another molecule of alcohol, that is CH3, CH2, OH, that is lone pair over here again. Now if you'll see that, okay, this is more partial negative and this is more partial positive. This lone pair attacks. Okay, and since it is in primary alcohol, this attacks takes place via SN2 mechanism. That means simultaneous bond breaking and bond formation process goes on. Okay, and finally the product that has been formed is CH3, CH2, O, H, CH2, CH3, okay, plus H2O, okay, and a protonated ether has been formed. Protonated ether has been formed. Okay, and finally this undergoes breaking. Okay, finally it undergoes breaking and the product is CH3, CH2, O, CH2, CH3. So lone pair and lone. Okay, plus H plus. So if you'll see this H plus that it was consumed at the start, now it has been regained. That's why it is also known as acid catalyzed intermolecular dehydration. It is also known as what? Acid catalyzed. Clear? Sure. Any doubts, any difficulties, guys? Any doubts, any difficulties over here? No one? Sure. Perfect. So once again, let us just glimpse up the entire reaction. It is 2 moles of CH3, CH2, OH, okay, in the presence of concentrated H2, SO4 or H3PO4, and the temperature is around 413 Kelvin, not more than that. If you increase the temperature, the product that is what ethene formation start taking place. Okay, and the product will be CH3O CH2O, CH2, CH3. So this is diethyl ether. Clear to everyone? Sure. So ethanol gets converted to diethyl ether. That's all about what? Intermolecular dehydration. Okay. Now talking about intramolecular dehydration. Okay. So I'll show you some of the reactions over here. The first reaction that I'm going to do over here is with CH3, CH2, OH. It is ethanol. Okay, and ethanol is a 1 degree alcohol. Okay, when this ethanol, it has been treated with two reagents. Okay, either one of it. The first one is concentrated H2SO4 or H3PO4. Okay, let me just increase this. Okay, or alumina, Al2O3. So in the first case, the percentage, or it is around 90% or 95%, 90 to 95% H2SO4, and the temperature required is around 443 to 453 Kelvin. The product that has been formed, okay, the product that has been formed over here is CH2 double bond CH2 plus H2O. That is ethene. In the second case, the second case I am going to take is about CH3 CH3 OH. So this is propane to all. This is propane to all, and which is in 2 degree alcohol. Which is in what? 2 degree alcohol. I'll take the same thing, but this time, in spite of 90 to 95%, what requires only 60% H2SO4. What requires is what? 60% H2SO4 or H3PO4. And the temperature requirement also decreases. And the temperature requirement also decreases to 363 Kelvin. Okay, or you can take it alumina as well. Or you can take alumina as well. That is Al2O3. But the only difference will be the temperature. At the first case, you might require around 623 Kelvin, but for 2 degree alcohol, you require only 523 Kelvin. And the product that has been formed, is CH3 CH double bond CH2 plus H2O. That is propene. Okay, clear? Talking about the last one. Third, CH3 CH3 OH, which is again a 3 degree alcohol. Okay, which is what? A 3 degree alcohol, that is 2-methyl propane to all. This is what? 2-methyl propane to all. Here it has been observed that only 20% H2SO4 is required, and even the temperature is around 343, or you just have to warm it. Okay, so the temperature that has been required over here, okay, that is 20% H2SO4 or H3PO4. Okay, 20% H2SO4 or H3PO4, and the temperature required is around 353 to 363 itself. Okay, so around 363 Kelvin. Okay, but the percentage of H2SO4 has decreased, and if you use alumina, the temperature decreases from 523 to 423 Kelvin. For what? Alumina. If I'll use alumina over here, Al2O3. But the product still remains the same. And that is CH3, CH3, CH3. That is isobutylene. Plus water. So if you'll see that the critical temperature and the concentration of H2SO4 or the acid, it keeps on decreasing. If I'll go from primary to secondary and secondary to tertiary, and this reaction or this set of reaction gives me a proper idea, okay, it gives us the proper idea that the order of reactivity, of alcohol towards dehydration, okay, the order of reactivity of alcohol towards dehydration is 3-degree alcohol, 2-degree alcohol, and 1-degree alcohol. So please remember this thing, guys. The order of reactivity is this. Is that thing clear? Any doubts, any difficulties? A very important segment over here, guys. Intermolecular dehydration. A very important segment. If you have any doubts, any difficulties, please let me know in the chat box. Any doubt, guys? Anyone? No one? Sure. Perfect. So this is the general reaction. Now I'll be taking this ethanol and I'll be discussing the mechanism as well. Okay, so let us discuss, and that too very quickly. I'm not going to go into great details of it. So yes, CH3, CH2, OH. Again, there is in presence of acid, there is in presence of lone pair, there is in presence of acid, there is in presence of what? Lone pair. So this lone pair, I'll donate it to what? H plus. Okay, the lone pair will get donated towards what? H plus, and the product that will be formed is CH3, CH2, OH2 plus. Okay, again what has been formed? Protonated alcohol. Okay, protonated alcohol. This is the first step. The second step is what? Formation of carbocation. There is a cleavage of this carbon to oxygen bond over here. This bond undergo hydrolytic cleavage where the electron is transferred to the other side, and you will get CH3, CH2 plus. So since there is a formation of carbocation, it can rearrange. Please make a note of it, guys. It can rearrange. So rearrangement is possible. Okay, so rearrangement is possible. And the final step is what? Formation of product. This hydrogen from here. Okay, let me write this hydrogen in this way. Can I write this thing as CH2 and H? Okay, so this hydrogen from here, it will break the bond and it will give the bond over here and will come out as H plus. So this is CH2 double bond CH2 plus H plus. ठीक है, क्लियर? सो क्या मिला अपने को यहाँ पे? ईथीन. वापस से अगर हम ध्यान से देखेंगे तो if you look it carefully, it is what? The generation of H plus. Again, that's why it is known as what? क्या कहेंगे हम इसको? It is acid catalyzed dehydration. Clear? कोई doubts, कोई difficulties? Anyone? Any doubts, any difficulties? Any doubts, any difficulties in the chat box? No one? Sure. Perfect. Let's proceed forward. The next one is a very simple reaction. Okay. The first one, this is the reaction. Okay. The first one is the reaction with HX, then PX3, PCl5, SOCl2 and everything. So talking about alcohol and halo acids, that is HX, it again undergoes what? Nucleophilic substitution reaction, that is SN1 or SN2 depending upon the alkyl group, and the product that you will be getting is RX plus H2O. Okay, and here is the concept of what? Lucas reagent as well. Here is a concept of Lucas reagent as well. Okay, that I will be discussing definitely with all of you. Okay, so this is let me just complete this thing first. If I talk about PCl3, you can take it as PBr3. For PBr3 also it is applicable, and for PI3 is also applicable. But since PBr3 and PI3 is not stable, these are prepared inside the reacting mixture by treating red phosphorus with bromine, okay, or iodine to give you what PBr3. Not balancing it, you can balance it by your own. But the product will remain the same. It will form 3 moles of RCl plus H3PO3 or POH thrice, or POH thrice. Talking about the PCl5, it will be RCl plus POCl3 plus HCl. Clear? So this is the product. If I want to give you a shortcut over here, I'll give you a shortcut as ROH Cl Cl PCl3. Just break it. You will get this product. Similarly for SOCl2, I'll give you a shortcut. Cl SO Cl ROH. Break it. So here both the products will be the same. You will get RCl plus SO2 will get evolved, and even HCl in the gas form it will get evolved. Now the question arises, what is the difference? The difference is the mechanism. If pyridine is used, it follows SN2 mechanism. If only SL2 is used, it forms SNI mechanism. Okay, that is intermolecular nucleophilic attack. Okay, clear? Sure. So this is the reaction, nucleophilic reaction. Any doubts, any difficulties, guys? Any doubts, any difficulties to anyone? Please let me know in the chat box. No one? Sure. Perfect. So that is all about what? Reaction with PCl3, that is phosphorus trichloride, pentachloride, thionyl chloride, and HX. Talking about the Lucas reagent. Okay, Lucas reagent is very important. What is first of all Lucas reagent? Let us just discuss that thing as well. Okay, let us discuss that thing as well. That is Lucas reagent. Lucas reagent is nothing but concentrated HCl in the presence of anhydrous ZnCl2. So please make a note of this Lucas reagent. Please make a note of this Lucas reagent. Okay, so this is what a Lucas reagent. And what is the importance of Lucas reagent? First of all, let me write the entire reactions first of all. Okay, so alcohol, that is 1 degree alcohol plus Lucas reagent, then 2 degree alcohol plus Lucas reagent, and then 3 degree alcohol plus Lucas reagent. Okay, so 1 degree alcohol plus Lucas reagent will give you turbidity. It will give you turbidity only after heating. That means if heating is not done, there is no reaction. Please make a note of it. Second, turbidity in 5 to 10 minutes. Turbidity in 5 to 10 minutes. Okay, and the last one, if it is a 3 degree, it is an immediate turbidity. Okay, that also proves the reactivity order of alcohol when it acts as a base or when there is a cleavage of R-OH bond. Clear? Sure. So yes, again you have to please remember this particular segment. You have to remember this particular segment. So I am putting this thing in a cloud so that you should remember. Okay, clear? Any doubts, any difficulties to anyone? Any doubts, any difficulties to anyone? No one? Perfect, great. So that is all about the reaction of PCX3, PCl5, SOCl2, Lucas reagent, and whatever concept was involved over here. Okay, one more thing that I can add. Sorry, one more thing I can add. For the first one, you can take mechanism as SN1 or SN2, depending upon the alkyl group. But the second one undergoes SN2. Okay, this also undergo SN2. Please make a note of it. And here I have already given the SN2 and this is SNI. Clear? Sure? Perfect. Let us proceed further. Now we'll be discussing about the oxidation. Okay, we'll be discussing about what? Oxidation of primary alcohol. Okay, so talking about the oxidation of primary alcohol. See, if I take an alcohol, okay, if I take an alcohol and that alcohol is, suppose primary alcohol can be represented as R, C, OH, okay, that is H, H, okay, clear. Now if you'll see there are two hydrogen, okay, there are two particular hydrogen that I need to highlight over here, okay, there are two hydrogen that I need to highlight over here properly is this. Okay, this is one and this is the another one. Okay, these are known as oxidizable hydrogen. These are known as what? Oxidizable hydrogen. Oxidizable hydrogen. These are known as what? Oxidizable hydrogen. That means if you'll bring a strong oxidizing agent or even a mild oxidizing agent, they'll undergo what? Oxidation. So let us bring an oxidizing agent, any oxidizing agent as a matter of fact. Okay, so I am bringing an oxidizing agent which gives us a nascent oxygen. Okay, this nascent oxygen, suppose it attacks, okay, it oxidizes this particular hydrogen. So it will form R, C, OH, OH, H. It basically forms what? Yeah, so H. This forms a gem diol or geminal diol. Now this gem diol is unstable. We know that it directly undergoes what? Dehydration. It directly undergoes what? Dehydration, and the dehydrated product is R, C, double bond O, H. So there is a formation of aldehyde. There is a formation of what? Aldehyde. And now if you see carefully, there is one oxidizable hydrogen still left. There were two. One has been oxidized. The another one is still left. Okay. So what happens? What happens over here is it further undergoes oxidation. Okay. It further undergoes what? Oxidation. Like this. Okay. It will form R, C, double bond O, OH. That is carboxylic acid. That is carboxylic acid. Okay. So one thing that you must have observed over here is started with, okay, it started with R plus 1 carbon atom. Over here also there is R plus 1 carbon atom, and over here it also has R plus 1 carbon atom. That means no carbon loss takes place, and there is no cleavage of there is no cleavage of carbon to carbon bond. So in this, can I say that when 1 degree alcohol, okay, when 1 degree alcohol is oxidized, when 1 degree alcohol is oxidized, it gives you aldehyde having same carbon atom. Aldehyde having same carbon atom. And when this aldehyde is further oxidized to carboxylic acid, it also has same carbon atom. Is that thing clear? Is that thing clear? Any doubts, any difficulties to anyone? Any doubts, any difficulties to anyone? No one? No. What are these oxidizing agents and what are the products that has been formed that we need to see in the next slide, and that is this slide. Okay. The first one. Please remember this thing, guys. Alkaline KMnO4, acidified K2Cr2O7, HNO3. These are the oxidizing agent which has been termed as the strong. These are the oxidizing agent which are known as a strong oxidizing agent. Okay, and it converts your alcohol. It converts your alcohol directly into carboxylic acid. For alkaline KMnO4, the salt of carboxylic acid will exist. Please make a note of it. For alkaline KMnO4, the salt of carboxylic acid will exist. But right now, I'm generally marking it carboxylic acid will be formed with the same number of carbon atom. When it comes about alkaline KMnO4, okay, when it comes about alkaline KMnO4, the color changes. Okay, the color changes from KMnO4 color is purple or pink in color. Okay, so the color changes from purple to brown. Okay, the color changes from purple to brown, and this brown color is due to the formation of MnO2. This brown color is due to the formation of what? MnO2. Okay, clear? Talking about acidified K2Cr2O7, it's orange color. Okay, it's orange color. We don't have orange color with me, so I'll take brown color itself. So it's orange color. Yeah, it's orange color changes to green. It orange color changes to what? Green, due to the formation of chromium sulfate. Due to the formation of what? Chromium sulfate. Okay, clear? Sure? No. Talking about these two reagents, chromium in dilute H2SO4 and chromium in acetone. Okay, they are known as Jones reagent. They are known as what? Jones reagent. Okay, for whenever it comes to chromium, I have a shortcut for you to remember. See, whenever chromium oxide, okay, whenever chromium oxide is being treated with aqueous solution, okay, or any aqueous thing is there, it gives you what? It gives you what? Carboxylic acid. It gives you what? Carboxylic acid. Okay, and whenever chromium oxide is been treated with non-aqueous solution, okay, it has been treated with what? Non-aqueous solution, it gives you an aldehyde. So please make a note of it. Okay, so in the first place, since dilute H2SO4 is aqueous, okay, it is what? Basically an aqueous or hydrous medium. Okay, so it will give you what? A carboxylic acid. Where in terms of chromium in presence of non-aqueous medium or anhydrous medium, it will give you an aldehyde. It will give you an what? Aldehyde. Similarly, chromium oxide that is in presence of pyridine, it will give you an aldehyde. And this one is known as Collins reagent. This one is known as what? Collins reagent. Okay. Then again PCC or PDC. Again you will get aldehyde. Copper and heat, again you will get aldehyde, and heat is around 573 Kelvin. So these are known as what? Mild oxidizing agent. These are known as what? Mild oxidizing agent. Why they are known as mild oxidizing agent? Because it will just convert your primary alcohol till aldehyde. It does not have that, it is not that strong that can convert aldehyde into carboxylic acid. It can convert aldehyde into carboxylic acid. Any doubts, guys? Any doubts to anyone? No one? So that is all the concept related to what? Oxidation of primary alcohol. Okay. Now, talking about the oxidation of 2-degree alcohol. So oxidation of 2-degree alcohol starts with this way: R, C, R, OH and H. Now if you'll see over here, guys, now if you'll see it carefully, I am highlighting this. Okay, I'm highlighting this, right? So this is what? An oxidizable hydrogen. This is what? An oxidizable hydrogen. So if I bring any oxidizing agent over here, so can I say it will convert into R, C, OH, OH and R dash. Let us take it as R dash. Again it forms a gem diol, which is equal to what? R, C, double bond O, R dash. That is a ketone. So one thing that we have understood, if I take a 2-degree alcohol, it gives you a ketone. Okay, if I take 2-degree alcohol and oxidize, it will give you a ketone. And the second thing that you should notice over here is there is no oxidizable hydrogen. There is no oxidizable hydrogen. And since there is no oxidizable hydrogen, the further oxidation is not that simple. If you want to further oxidize it, you have to bring a very strong oxidizing agent. Okay, you have to bring what? A strong oxidizing agent. Let me mark that thing. So you have to bring a what? Strong oxidizing agent, and then you have to heat it. Strong oxidizing agent, and you have to heat it. And in this case, there is a cleavage of this bond. And the product that has been formed is RCOOH plus R dash C. They both will form what? Carboxylic acid. They both will form what? Carboxylic acid. There will be a 2 segment that will be forming is what? Carboxylic acid. Okay, and here one note may be taken that if formic acid is formed, okay, formic acid cannot sustain this strong oxidation process, and it undergoes combustion reaction to give you CO2 plus H2O. Okay, so it cannot sustain, and it will directly give you what? CO2 and H2O. Okay, so with this thing, can I say that 2-degree alcohol, if you take 2-degree alcohol and try to oxidize it, okay, if you take 2-degree alcohol and try to oxidize it, the product that you will be forming, the 2-degree alcohol will be giving you a product what? Ketone. Okay, he will give you what? A ketone with same carbon atom, okay. But when ketone undergoes vigorous oxidation, the step is known as what? Vigorous oxidation. It's not normal oxidation, it is what? Vigorous oxidation. On vigorous oxidation, it will give you what? Carboxylic acid, and it will have at least 1 carbon less. It will have at least 1 carbon less as compared to what? Alcohol, or as compared to what? Keto. Clear? To give you an example over here, let us take an example of CH3 CH3OH. This is an isopropyl alcohol. Okay, and what I am using is let us take acidified K2Cr2O7. Okay, here you can take you can take strong or mild oxidizing agent that we have discussed in primary alcohol. It's just the same. You take strong or mild oxidizing agent, it doesn't matter, but over here it has to be a strong oxidizing agent like alkaline KMnO4 or acidified K2Cr2O7 or HNO3, that is nitric acid. So it will convert. Let us coming back to the question. This isopropyl alcohol will get converted to what? CH3 C double bond O CH3. Okay, clear? And this is what? An acetone. It has a 3 carbon atom. So does it has a 3 carbon atom. Now, even if I'll use this acidified K2Cr2O7 in excess, K2Cr2O7 in excess, there is no reaction until and unless I'm going to heat it. The moment I heated it, there is a cleavage of this bond, okay, and this segment will get converted to carboxylic acid. Even this will get oxidized to carboxylic acid, and there are two products formed, CH3 COOH plus HCOOH. There is a fragment of acetone in which one fragment consists of two carbon atom. That acid will form. The another fragment consists of one carbon atom. Even that acid is will form. But since there is a formation of formic acid, we know that it cannot survive and it will undergo combustion to give you CO2 and H2O. Okay, and hence there is a formation of what? Acetic acid. But the problem over here is it just consists of two carbon atoms. The problem over here is what? It just consists of what? Two carbon atom. Clear? Sure. Guys, any doubts, any difficulties over here? Any doubts, any difficulties over here? No doubt. Perfect. So that is all about what? Oxidation of second degree alcohol. Talking about the last one. Okay, talking about the last one, that is oxidation of tertiary alcohol. Okay, that is what? Oxidation of tertiary alcohol. And tertiary alcohol, I am going to take example as R dash, CH2, R double dash, OH. Okay, in presence of Jones reagent, PCC, PDC, Collins reagent. Okay, there is no reaction. Okay, in presence of alkaline KMnO4, acidified K2Cr2O7, no reaction. But if you heat it, you'll get carboxylic acid. You'll get what? Carboxylic acid. And this reaction will first proceed by elimination, formation of alkene, and then giving you what? Carboxylic acid. Okay, and then last one, copper and heat, it will give you an alkene. It will give you an what? Alkene. Let us understand this example. Let us understand this thing with the help of an example. That is CH3 CH3. Let us write it from the top. So CH3 CH3 OH. Okay, so we are going to oxidize it. Okay, the first step is what? The elimination step, and in elimination this has been formed, CH3 CH3 double bond CH2. Okay, and then it further undergoes oxidation. So first, if you are going to oxidize it, then second again you are going to oxidize it. The product that will be formed is CH3 C double bond O CH3 plus HCOOH. It cannot survive, so it will give you what? CO2 plus H2O. So there is a loss of at least one carbon atom. Proceeding further. Since it is a vigorous oxidation, we are heating as well. It will further undergoes oxidation, and the product is what? CH3 COOH plus CO2 plus H2O. Right? So this is how 3 degree alcohol undergoes oxidation. So it consists of 4 carbon atom. Alkene, this is an alkene, consists of same number of carbon atoms. There is no loss in number of carbon atoms in alkene. Then further, when it is oxidized, it will give you a ketone. Ketone has 3 carbon atom, and finally carboxylic acid, which has 2 carbon atom. And finally an carboxylic acid, which has what? 2 carbon atom. Okay, clear? Sure. One thing just to give you an idea, R C double bond O R dash, and if you are trying to oxidize it in presence of heat, always remember that the cleavage of this ketone will always takes place in such a way that the C double bond O group, okay, the C double bond O group will go with an alkyl, with a smaller alkyl group. Okay, C double bond O group will go with alkyl, that is smaller alkyl group. So if I take this is a large alkyl group, and if I take it is a small alkyl group, right? So the rule is CO group goes with small alkyl group. Why I'm saying so is, suppose if I have a ketone something like this, CH3 unsymmetrical ketone, C double bond O, C2H5. There are two types of possible cleavage. The first cleavage is this type and the second cleavage is this type. So let us take this is an A type cleavage. So in this A type of cleavage, can I say I'll be getting H, COOH, right? This will get converted to carboxylic acid and plus 3 CH3, CH2, COOH. And suppose this is a B type of cleavage. Okay, this is what a B type of cleavage. And in this B type of cleavage, can I say I'll be getting CH3, C double bond O, OH plus CH3, COOH, right? So in this case, if you'll see that there are two different products formed, there are two different range of products formed, and that's why here this rule is very much important. It says that during the cleavage of ketone at the time of oxidation, CO group, that is carbonyl group, will go with the smallest alkyl group. Okay, will go with the smallest alkyl group, and since the smallest alkyl group is CH3 group, this B type of cleavage is not possible and A type of cleavage is possible, and hence the oxidation of butane to one gives you 2 moles of carboxylic acid. Is that thing clear to everyone? Any doubts, any difficulties, guys? Is that thing clear to everyone? Any doubts, any difficulties over here? And it's a very important segment, guys. This oxidation of alcohols, whatever we have discussed, okay, this entire oxidation, okay, this is very, very, very important, guys. Oxidation of alcohols. You can expect one or the other question from this. Not direct question, but yes, this will be the part of the questions. Okay, so please make a note of it, guys. Okay, clear? So that is all about what oxidation of alcohol. Let us just glimpse of entire oxidation of alcohol over here. Okay, so let us just glimpse of entire oxidation of alcohol. I'll rather say just 1 degree alcohol gives you 1 degree alcohol will give you what? Aldehyde. Okay, and in aldehyde there will be same number of carbon, which will again give you what? Carboxylic acid with again same carbon. Okay, then 2 degree alcohol on oxidation, these are normal strong oxidizing agents oxidation. Okay, it will give you ketone with what? Same carbon. Okay, here, but over here we need to do a vigorous oxidation, and then you'll get carboxylic acid with at least 1 carbon atom less. At least 1 carbon less. Okay, clear? Last one, 3 degree alcohol will first give you an alkene. It first give you an alkene, and over here you'll have same carbon. Then second, it undergoes oxidation to give you ketone with at least 1 carbon less. Okay, last one, okay, is what? Vigorous oxidation. Last one is what? A vigorous oxidation, and you will get a carboxylic acid with at least 2 carbon atom less. At least 2 carbon less. So this is the entire glimpse. Okay. Hello Pooh. So this is what the entire glimpse of what? Oxidation of alcohols. Is that thing clear? Sure. Clear. So that's it, guys. I'll be stopping over here. I've tried to cover as many content as possible in today's session. Yes, there are some contents remaining that we'll definitely discuss in another session of one short video of alcohol, phenol, and ether. Whatever we have discussed till now, we'll skip that session, and then we'll be proceeding forward to discuss the remaining part of the chapter. Till then, guys, thank you so very much for joining this session. I hope that you must have understood today's session very well. And if you have understood and if you have enjoyed the session, please do not forget to give a thumbs up in, and always, okay, and please convey whether you have understood and how you have what was the experience related to this session in the comment box. So with this thing, guys, thank you so very much. New to the channel, please make sure that you are going to subscribe the channel and do not forget to press that bell icon. Last but not the least, do like, comment and share this video to all your friends. Let them take the benefit of this entire session of the series Chak Day. Thank you so very much, guys. God bless you all, and yes, we'll meet soon. Take care.